We've discussed before that the square root of a negative number is imaginary. So, if you ever have a negative sign underneath a square root, you just take the square root and then you put an I next to your answer. So for example, the square root of negative 1 is plus or minus 1, because the square root of 1 is 1, with an I next to it. You won't often see people write the 1, so you'll usually just see that the square root of negative 1 is I. So the same type of thing will happen with the square root of negative 16. The square root of 16 is plus or minus 4, and then since we have the negative underneath, we put an I next to it. Sometimes we have to work backwards. So I just told you that the square root of negative 1 is plus or minus I, or plus or minus 1I, whichever way you think about it. So if we were to get rid of the square root by squaring that and canceling out the square root sign, we would be left with negative 1. And if we squared this side, we would have to square the other side, which would leave us with I squared. So this is another fun little fact we're going to be using a lot, the fact that I squared equals negative 1. So let's just practice simplifying. It's everything we did before with square roots except for i's next to our answers. So first I'm going to copy the 3 down. In between the 3 and that root sign, the radical sign, there's a multiplication sign. So let's take the square root of 16, it's 4, and then the negative sign means we put an I next to it. And now we just need to multiply the 3 and the 4 together, which is 12i. And then you can go ahead and put your plus minus sign out front. 1b is pretty similar, so when you do that problem, hopefully you come out with plus or minus 10i for your answer. In 1c, I'm just going to recopy that negative sign out front. It's really a negative 1, so you can write a 1. And then we need to take the square root of 75. It's not a perfect square, so off to the side, I'm going to try to factor tree it. Well, I know that 3/4, if I have 3/4 in my pocket, that's 75 cents. So 3 is prime, and 25 divides into 5 and 5. So I have a pair of 5s and a 3 left over. So the square root of 75 is 5 square root 3, and then that negative sign turns into the I right next to it. So the negative sign out front, we would just multiply by 5. So we'd have negative 5 times the square root of 3. And the last thing we do, aside from, I know this answer was negative, but we normally put a plus minus sign out front, is the convention says that instead of putting the I at the very end, we're just going to move the I so that it's in between the normal number and the radical sign. So the final answer will be plus or minus 5i square root 3. Oh no, 1d has a fraction. Well, we're just going to write the fraction out front and multiply it by the answer we get when we simplify the square root of 63. It's not a perfect square, so I'm going to factor tree it. 7 and 9 go into 63. So 9 can be divided into 3 times 3. A pair of 3's comes out. We have a 7 left underneath. So the answer to that, square root of 63, is 3 square root 7. The negative underneath means we need an I in the answer. And now we're going to take care of rearranging. So let's multiply negative 1/3 times 3. That's just going to be negative 1. Next we have the square root of 7, and I'm just going to move the I from the very end to right in front of the radical sign, right there. And then you can put plus or minus 1i square root 7, or just plus or minus I square root 7. Now that we know how to simplify, let's go ahead and put that skill to use. Let's solve for x. So we're going to square root both sides. Pew, which will leave us with x equals plus or minus the square root of 81 is 9, and the negative sign underneath turns into an I. So that's it, plus or minus 9i. This problem should look pretty familiar. We just need to get the x squared all by itself. So first we'll get rid of the 75 by subtracting, which will leave us with 3x squared equals negative 75. Next we need to get rid of the 3, so we will divide. So x squared equals negative 25. Last step is to square root. So we have x equals plus or minus. The square root of 25 is 5. And the square root of a negative sign is I. So that's it. A complex number is when we have a real part and an imaginary part. So the real part is represented with the letter A, and then you either add or subtract to it the imaginary part, and that part is called BI. So we're going to fill in A is the real part, so the part without an I, and B is the imaginary part, which is the part with the I. So what we're going to do is take two complex numbers and set them equal to each other, and then solve for the letters that they're asking for. So in order to do that, we set the real parts equal to the real parts, and then the imaginary parts equal to the imaginary parts. So if I were to color code this right here, and we were to solve the A and the C on each side of the equal sign, see how neither of those have I's next to them? That means those are both the real parts. All right, real and real. And then see how the B has an I next to it and the D has an I next to it? We would set BI equal to DI because those are both the imaginary parts. So let's try it. We need to solve for x and solve for y. So I'm going to look on the left side of the equation. The 3x doesn't have an I next to it, so that's a real part. Let's look on the other side. On the other side, the 6 does not have an I next to it, so that's the other real part. So we're going to set 3x equal to 6 and solve. So it means we're going to get x equals 2. All right, we're halfway done. Now we need the imaginary parts. So here's a 5i, and I'm going to include the negative sign in front of it, so that's the imaginary part. And on this side, here's the I, and it's connected to all of this. Don't ask me why they put parentheses around the 10y, I don't know, but all of those things go together. So we're going to set negative 5i equal to negative 10yi. So the first thing we're going to do is get rid of the i's because they're on both sides. So they're both gone. And now we just have to solve for y. So the 10 is next to the y, the negative 10. So let's divide both sides by negative 10. And negative 5 divided by negative 10 is positive 1/2. See if you can just go ahead and label the real parts and the imaginary parts in example B. If you labeled like this, you are correct. Now let's set the blue numbers equal to each other. Negative 4x equals 12. So you should get x equals negative 3. And then we'll set the red parts equal to each other. And remember, all of this counts as 1. Negative 49yi. Again, I don't know why the book writes the parentheses. So first thing, cancel out those y's. And we need to solve for y by getting rid of the negative 49. Divide by negative 49. And that leaves us with positive 1/7. These directions want us to solve the quadratic functions for the zeros. So let's see if we could try the first way we learned. This is set equal to 0. So let's see if we can factor this. Let's see if we can find factors of 5 that add up to -2. And I don't think we're going to be able to do it. So I'm very sorry, but factoring isn't going to work. So we're going to do the next thing we learned, which is completing the square. So let's get rid of this because that didn't work. I'm going to move the equals 0 over to the other side. So now that it's all set up like this, we can follow the completing the square steps. First, you got to make sure a is 1, and it is. Next, we need to move c to the other side, so I'm going to move the 5 over. So we have x squared minus 2x. I'm going to leave a space for the perfect square that we're about to complete. 0 minus 5 is -5, and if I add a square on the left, I have to add a square on the right. So what are we going to put inside the square? What do we put right there? We take b, which is -2, divide it by 2, which is -1, and square it. -1 squared is 1. So we're going to add 1 on both sides. Next, we factor the left side. So what times what equals 1? 1. And -1 minus 1 will give us -2. So in parentheses, it's x minus 1 squared. When we combine those two, -5 plus 1 is -4. And now we just need to square root both sides, which leaves us with x minus 1 equals plus or minus the square root of 4 is, I was going to say 4. The square root of 4 is 2, and that negative sign turns into an I. So the last thing we need to do is get the 1 out of this side, so we're going to add it. And the proper way to write the answer is in the complex number form, where the real part is first, and then either your plus or minus sign, and then the imaginary part is second. So we are going to write the 1 first, because that's the real part, it's a positive 1, and then we'll put the plus or minus 2i, because that's the imaginary part. And now we're done. So this is a problem that did not cross the x-axis at all, because these roots are imaginary. They are floating somewhere up above the x-axis. So let's try solving for b. Let's just try factoring first. Let's find the factors of 35 that add up to 10. 1 and 35, 5 and 7, and that's it. So it doesn't look like that's going to work. I'm so sorry. So we got to complete the square again. Great practice for you. So let's go ahead and set this equal to 0 rather than rewriting it. I'm just going to ignore that for a second. Put the 0 on the right. The leading coefficient's 1, a is 1, so we can go ahead and move c over to the other side. So I'm going to subtract 35 from both sides. So I have x squared plus 10x. We're about to fill in the square right there. It's going to equal -35 plus whatever we fill in the square. So what's going to go in the square? It's going to be 10 divided by 2, which is 5. 5 squared is 25. So we're going to add 25 on both sides. So let's factor this side. All of that we're going to factor. So in the parentheses, it's going to be what times what equals 25 and adds up to positive 10. How about x plus 5? 5 plus 5 is 10. 5 times 5 is 25. Let's add over here, -35 plus 25 is -10. Next we get a square root both sides, That leaves us with x plus 5 equals, the square root of 10. We could try factor treeing 10, but nothing's going to happen. So what we do in this case is we write our plus minus. We write down the fact that the square root of 10 is as low as that can go, but we do have to take that negative sign out and turn it into an I. And remember how we don't write the I at the very end? We write the I in front of the radical sign. So the last thing we need to do is get rid of the 5 by subtracting it. And we will have x equals the real part first, so negative 5, and then plus or minus, and then the imaginary part, I times the square root of 10. And that's it. Another floating parabola that does not cross the x-axis. The last example looks fancy, but we've been doing it this whole time. It's called the complex conjugate of any complex number. So if we have a plus bi, you have to make sure the a, there should be a space there, the a is first and the bi is second, okay? The real part always goes first. The imaginary part always goes second. So if you have a plus sign, the complex conjugate is a minus bi. Alright, so all we have to do is flip the sign in front of the imaginary part. So we've been writing the complex conjugate this entire time because we've already been writing plus minus in front of our answers. So now we're just going to take one complex number with either a plus or minus sign and then flip the sign so that we can be fancy and say what the complex conjugate is. Because if one of them is a root, a 0 of a quadratic, then the other one is. So let's make sure we have the real part first. Negative 15 is the real part. And the 2i, it's positive, so plus 2i, is the imaginary part. So that's not the answer. I've just rewritten it in the proper form. The complex conjugate is when we flip this sign. We do not have to touch the sign in front of the real part. We only flip the sign in front of the imaginary part. So the answer here is negative 15 minus 2i. That's it. Well, 5b is interesting. There's only one piece to it. So I have my blue pen ready, but I don't see any real parts. So that means the real part is 0. And then the imaginary part is the minus 4i. So in order to take the complex conjugate, we switch the sign in front of the imaginary part. So it's just going to flip to positive 4i. We could write 0 plus 4i, but we really don't need to. We can just write 4i and be done. Check and see if 5c is written in a plus bi form with the real part first and the imaginary part second. And guess what? It is. That's the real part. This is the imaginary part. So all we have to do is flip that sign to a minus. So we keep the negative 10 and we write a minus 2i. Done. And hopefully you get negative 20 plus 3i for the last one, because this time you have to switch that sign in front of the imaginary part from a negative to a positive. And don't touch the sign in front of the real part. You only switch the one in front of the imaginary.